Hi everyone, I'm Nick. Today I'm going to be telling you how Skyrim saved my code base and can save yours too. And if you don't know what Skyrim is, we'll also talk about that as well. Before I continue, everybody can hear me okay? Okay, great. So 2008, let's take us back there for a moment. And that was the year that a game called Fallout 3 came out, another video game. And this video game kind of completely just rewired my brain. I was probably too young to be playing it. You could do the math on my college graduation year and LinkedIn and all that. But essentially what you're looking at now is sort of this like step out moment in the game. It's an open world role-playing game, a virtual world where you can get fully immersed and lost in. And what's incredible about this was it was one of the first product experiences I had where I said, I can't stop thinking about it after playing, and I can't stop thinking about it until I play again. And it really just threw me back in my seat fully. So you got to ask, how did they make it? How did they make this game? 2011 rolls around. Another video game comes out called The Elder Scrolls Skyrim, and it's like, whoa, way, way bigger, way more detailed. A lot of that same love and passion carried over through. Fallout's post-apocalyptic. Skyrim is a fantasy setting. Both of these games are games where you go in the world, be who you want, and do what you want. And again, the game did pretty okay. It's in the top 10 best-selling games of all time. And it's sold over 60 million copies, unparalleled levels of immersion. Even today, if you go back and play it. That's why they've released it like 40 times. And I had to ask this time, okay, so like last time I was wondering how they made it, but like, okay, how'd they make this one? Because it's even bigger, more expansive, and better, right? And it took me a while to find the answers. I was always looking for interviews online, reading articles, and overall trying to figure out the staff, the dev, the forums, like maybe random off-brand accounts that they're posting from anonymously. And I eventually found it. And what I actually found unexpectedly has sat with me ever since, because it's also how we can set ourselves up to build great software. With that cliffhanger, I'll say real quick, I'm Nick Gerace. I'm a software engineer at System Initiative. And I previously worked at SUSE, Rancher Labs, and NetApp. So my whole career, I've been bouncing around software infrastructure, writing a lot of Python and Go in the past, and more recently, pretty much all of our backend services at System Initiative are in Rust, with our front-end stuff in TypeScript using Vue 3. I was the 5th person at System Initiative, so NetApp was super huge, first place in my career. Rancher, smaller. SUSE bigger again, and then I joined as the 5th person. And now we're a team of, I think, almost 20, above 15, 18, I believe. So yeah, so from this talk, you'll hear some of the technologies we use, because I'll be using real-world examples. I write a lot of Rust and TypeScript, as I said. We use Tokyo, which is our async executor layer in our Rust code, Nats for our communication, Vue 3, Postgres, Nix, and more. Back to the talk. Skyrim saved my code base and can save yours too. I'm like kind of lying here. It didn't really save my code base. Like I took stuff I learned when I was too young to be playing those games, and I carried that forward to like save my code base in advance. But I also want to talk about the second one. Don't want to sell snake oil. Don't want to speak in platitudes. But I want to convey the experiences I've had and give them all to you. Okay, so back to where we were. Who made this thing, right? Because I said, how did they make this? Well, first you got to start with the who. They made it. Bethesda Softworks is the publishing branch founded in Bethesda, Maryland. And Bethesda Games Studios, the specific studio who made Skyrim and Fallout 3, is in Rockville. They're hometown heroes. A lot of people don't know that. Most game publishers are in Santa Monica. They're in New York. And there's only one problem. Right, we're in Northern Virginia. Like whenever we see a plate of those colors and that shape, we get like, ugh. So like, okay, but anyway, Maryland license plates. Moving on. 2012 rolls around. So the game's been out, I think 11/11/11, it came out November 11th, 2011. And I'm like going everywhere for these interviews and like trying to figure out, okay, what does it take to make something like this? And I found a gold mine. So Todd Howard, pictured on the right, was the game director for the Elder Scrolls V Skyrim. And at DICE 2012, a games industry conference hosted by the Academy of Interactive Arts and Sciences, he gave a keynote titled, "Why We Play, Why We Create." It's an excellent talk overall. I recommend you watch the whole thing. It's not all analogous to what we do, but it did reveal something particularly big. And this is the aha moment. So at one segment of the talk, this is how they typically make games in the industry. They start by designing, then creating, then playing, and then changing, then playing again and polishing. Pretty similar to software development. But the big thing is this. The bottom scale is the one we want more. We want to get to that first play faster, because everything after that is the opportunities time. These slides are ripped directly from his talk. It's hosted on YouTube. I'd be happy to send a link for anyone interested. In fact, they're just screen captures of the YouTube video. And that is the most important bit. Everything we do in software matters at that opportunity time moment. You can plan all you want, but the opportunity time is the most important. Do more of the great stuff, do less of the crap stuff. In essence, this is the way that we build great software. So that's the aha moment in a nutshell. Some direct quotes from Todd in the talk. That's where the good stuff mostly happens, as I already said. Maximize opportunity time and get here faster. Here being that, wrong way. Here being that arrow. So this is from my CEO, Adam Jacob at System Initiative. Adam has been a mentor of mine for a long time. You may recognize him. He's the co-founder of Chef. And now he's the CEO and co-founder of System Initiative. He once told me in a great conversation about writing software that stability isn't achieved through advanced precision, but through the accretion of learning about the domain and refactoring. I kind of took that quote and changed it a bit for today. Great software isn't made through advanced precision, but through the accretion of learning about the domain and refactoring. So I guess, if you want to give me attribution. And by the way, he said that other thing just like on the fly. So it goes to show you how great Adam is. So learning about the domain, refactoring, opportunity time. How can we make better software faster? And this is the big goal of the talk. We want to enable and maintain our code base to maximize opportunity time. If you read the abstract, there are 5 main questions that I want to tackle today. But this is what we should have in the back of our head the whole time in reaching that goal. So again, some talks divert from their abstract, and that's okay. Things change when you wrote the abstract. You're like, ooh, I actually don't want to talk about that, or this looks kind of different. But in this example, I decided, you know what? I wrote these 5 things. I'm going to hold myself to my word. We're going to answer them together. So if you have some semblance of how to answer these questions by the end of this talk, I did my job. So I'll just say them real quick. Can we perform large refactors? How do we handle feature branches? Can we introduce new technologies or phase out old ones? Can we onboard new people into the code base? How do we make handling tech debt easier or just reducing it altogether? Some goals and non-goals before we get into this section, and make sure my stopwatch is up. I'm going to give some brief introductions to strategies and options for solving problems, and this will be reflection on my own experience in my own careers. Everybody has different varying levels and years of experience, and I want to tell you things that are in my experience and not this will work for you too. So this is basically just brief introductions on how we do this. This talk is not meant to be a full feature-length talk with every single strategy, but is meant to be brief exposure on where to go next after you leave this room, or follow-up questions afterwards. And again, not trying to sell you snake oil, platitudes, or hand-wavy guidance. Every organization is different. This is about how we think together to maximize opportunity time. So let's tackle all 5. Starting with the first one. Can we perform large refactors? And if there's one thing, and I really debated making this its own slide, but I decided not to. There's one thing you should take away from this talk. Code bases are living, breathing things. Every commit you make is not a change to the code. It is the change in behavior to everything using that code. So a diff is not just code in a diff, it's a change to the system in actuality. One of the biggest things that has helped me perform large refactors in the organizations I work in is domain-driven design. Domain-driven design, coined by Eric Evans in a book written in 2003 that to this day has aged wonderfully, although the technologies and problems they were dealing with are slightly different than now. Essentially bounding things by their domain and writing software and laying out the code base in such a way that we all speak in a ubiquitous language, a way that the shareholders, who I'm building the software for, who I'm building it with, everyone, dev, QA, customers, internal, external, we're all speaking a ubiquitous language, and that helps us lay things out by domain and makes the software supple. Supple software is software that can be changed easily. It's not coarse, it's not obtuse. You rip something out, all the cards don't come falling down. And I'm not going to go into domain-driven design more deeply here, but at a high level, the way you lay out your software, it is by its domain, not necessarily by its function, but what it does to the product and software you're trying to build. What is its purpose in the code base? The modules you have, the smaller libraries, all of that are domain bounded. So some examples of system initiative of how we perform large refactors. One trick is library and binary crate separation. So this is kind of interesting. Crates, because we write a lot of Rust, are like basically little sub-modules, NPM package equivalents, that kind of thing. Every server has its own library. So the text is a little fuzzy, but you can see we have rebaser server, pinga server, shuttle server. All these are instances that can be spawned in a thread. We specifically write our software in such a way that all of our servers, they're separated out from the final crate that builds the binary. That's just command line flags, configuration, and spawning the server itself. So if you need to create an omnibus binary, let's say you need to spawn 5 different server instances in one binary, we can do that. Or if you want to spawn multiple threads in one binary, multiple instances. That kind of flexibility has been critically important, and integration test is made easy because we're not really worried about the runtime configuration of the binary. We're worried about the server as a asynchronous thread. Whether it's green thread or real thread, there are multiple different ways out of it. And we also rely on intention-revealing interfaces, a pretty self-explanatory concept from domain-driven design. We name things literally at System Initiative. So intention-revealing interfaces draw from ubiquitous language, a quote from the book. Essentially, so long as we're all speaking the same language and the interfaces we write say literally what they do, we can get functions and methods with fewer side effects and are overall more intentional. Second question, how should we handle feature branches? So releasing software isn't strictly tied to Codebase layout, of course, but they do kind of form one another. My biggest advice and what I've seen work in the real world is know your options or choose your poison, choose one and commit. The Codebase serves to build the product, but it itself is not the product. A great use case of this is Red Hat. Red Hat Enterprise Linux is licensed and is built by Red Hat, and you can get a license to use it from Red Hat, and the Red Hat software is open source. The Red Hat open source Codebase is not Red Hat the product. And this is true for all Codebases, whether it's open source or not. So the ideal when we talk about deployment and releasing is to get to somewhere to the 10 deploys per day at Flickr talk in 2009, where we're constantly deploying, we're constantly releases. That is the ideal. We can get quicker feedback faster, and anyone can try the system at any change in time, because code bases are a living, breathing thing. Any change we make affects the system. Some options we have are point release with release branches, rolling release, having release candidates, whether you're doing rolling release or not, or point releases. But my 2 favorite, if you can handle it, are short-lived feature branches, because any change you make to the system, and feature flagging. So System Initiative, what we do is we operate on a rolling release model. Every release to main is a release to the system. And we specifically do not do release branches with point releases. The reason why I'd advocate for this is that what you essentially do is if you see everything as a behavioral monolith moving forward, and every time you rebase your PR after it being stuck in rebase hell for a month, it is not going to have quite the same behavior it had, even if your diff is precisely the same. Sure, if it's sandboxed in its own section of the code base, that's fine. But if it's interacting with the rest of the system as a whole, we try and get those branches in as fast as possible and make them short-lived. Because every change doesn't just change the code, it's the behavior of the system. The problem with feature flags is you can have leakiness. So let's say something's feature flagged off in the front end, you're running a full stack SaaS app. In the back end, it still might be collecting that stuff on main. Though I'd argue release branches aren't immune either. At Rancher Labs, we used a lot of release branches, and it turns out when you cherry pick a commit, you may think it behaves similarly because the diff is different, but the behavior of the system may be subtly different based on the surrounding code. Third question, can we introduce new technologies or phase out old ones? So this is pretty much relying on a lot of the domain-driven design principles we spoke about earlier. Domain sandboxing and third-party integration sandboxing are two big methods. We want to release domain bleed. So, and this also includes tests. So let's say you're in your repository and you're adding a wrapper around an AWS SDK, right? Do you write the generic AWS SDK wrapper, or do you write one specific to your use case? It's going to depend on a case-by-case basis. If you're using it frequently and your code base, the purpose of it being there is to be a generic wrapper, then that's where you should go. But if you're only using it for one or two technologies for the domain, if the domain is, I just want to ship stuff to a data warehouse via AWS Firehose, then perhaps scoping your crate and tests, and I keep saying crate, that's the Rust package, but scoping your tests to that is very important. And you'll see that sometimes you add a bunch of tests to initially add this stuff and you delete them all. Maybe you start with smaller integration tests or smaller unit tests, and then when it reaches the rest of your service, you're testing your big API server, you just delete all those tests and the big tests serve it. So some examples at our company was exactly what I just said with the data warehouse client. It purely speaks to NATs and AWS Firehose in our example, and we did not write a generic AWS SDK implementation. It's the only crate that has it, but this allows for wholesale deletion in addition to the code base because the domain-based object is that it's a data warehouse crate, data warehouse client crate. What we needed to do was take information out of the running system and send it to our data warehouse. So again, relying on some of those domain concepts, we named it literally what it does, and it's the only thing that wraps the AWS SDK in the code base. And another example is the steady takeover of NATs, our communication layer protocol we use to talk between all of our services. I wouldn't quite say we run a distributed monolith, but we don't have a bunch of microservices either. We have primarily 5 backend servers that can scale accordingly horizontally and vertically if they need to. And at one point, what we needed to do was there was one instance of System Initiative, well, one server within System Initiative called the rebaser server, and we needed to swap out the communication protocol to NATs. Because we had an SI RabbitMQ crate that was specifically tailored to using a durable queue, we were able to swap it out easily. It was a wholesale deletion. The integration test, because we didn't bound them too much to that crate, just worked afterwards because we were testing the domain and the behavior of the software, not the code itself. So short-lived feature branches were also made easy due to this. You start to see these questions start to interfere with one another. Okay, I'm doing pretty well on time. How can we onboard new people into the code base? Is our next question. So this is a bit of a rehash, the intention revealing interfaces. I go look at the software, I kind of understand what it does. Long-living documentation is a big thing as well. Fewer version string baked in your markdown files. Maybe you do have something specific for versions, like for version v2.3. I would recommend putting that in a separate section or markdown file and keeping your README and everything a little more generic to the high-level ideas and guide. Self-documenting code, struggle with this one a bit because somebody will send you the fast Fourier transform equation used in the original Quake code by John Carmack, and that thing is a whole bunch of math and numbers. And you can write as many literally named function names as you want, but sometimes adding strict documentation alongside the code is good as well. I would say, again, sticking away from platitudes, it's going to be best for you and your specific use cases. But let's go back to testing for a second, the sort of walk it forward, walk it back thing. So delete and refactor tests is extremely important. They can go extremely stale. Every once in a while, doing a clean sweep to making sure your tests map to behavior for integration tests and not code itself, this zombie code testing. What is it doing for my system? Are we actually testing everything we need to? Are they giving false positives because the feature itself has moved? So how do I build and test my changes in a code base? New contributors should be able to answer that question very quickly. And I'll give you examples of how we did it. So we use a Nix flake at the root of our repo. Nix is a immutable package manager, and Nix OS is a Linux distribution written around it. We have people on Macs and several Linux distributions. If they install Nix, they just type cd, enter the repo, and all their dependencies are downloaded and available for them in the environment. And they're all locked to a specific inversion. Death of the bootstrap script. We had a bootstrap script that would run like apt install, DNF install, brew install, and it was a mess. Everybody was on slightly different versions. Other things we do is we have no acronyms. This is one thing that I really recommend to a lot of folks. Acronyms are gatekeeping at times because they're like, hey, yeah, I know about the XYCD server. I wrote it. Oh yeah, XYCD behaves like X, Y, and Z, and and it brings in the BCF protocol, and your engineers are like, I have no idea what this means, and your new hires are like maintaining a glossary, and you have a Google sheet that's a new hire maintains, and it falls apart after 3 months, it atrophies, and then starts up again next year, and you eventually just give up on it. So that leads us to literally named entities. I'll give you 3 examples in our code base. We have the rebaser, which rebases changes made to the system. The forklift, which forklifts data from the system within the external pipelines. Data warehouse client is what forklift uses to send stuff to our data warehouse. And shuttle. It shuttles the NATS jetstream durable queue messages to another NAT subject. Literally named interfaces, contributors can quickly understand where to go. So then our last question. How do we make handling tech debt easier or just reducing it altogether? The answer to the previous 4 questions are the answers here. You start to realize there's a lot of overlap. You get this one just partially by doing the others. Supple Codebases enable wholesale deletions and additions. There are several PRs if you enable some of these aspects of domain-driven design, where you can just simply delete out a crate because you're not deleting out a crate or a submodule or an instance of your code base by technology. We're not getting rid of the AWS SDK. We don't need the data warehouse stream client anymore. Because the behavior is what you have reflected in your code base, not Cove. If I remove the behavior and it's separated by domain, or I hot swap it, the system should understand, should be able to behave in a way such that this behavior has been removed, added, or deleted. Can the rest of the system behave accordingly? So I keep using words like behavior and domain, and the thing that, again, that big thing I wanted to get through is that code bases are living, breathing things. And you maximize your opportunity time by treating them that way. So some examples for us, we don't really have any util modules or crates. And I've been at a ton of places that have. If anyone here has written Kubernetes operators, you know there is a util.go somewhere in there that does a whole bunch of random shit. And sometimes they're generally useful, right? Like some math or timestamp functions. But generally speaking, we've stayed away from that. And a lot of things we do is knowing when to make that stuff global or localized. An example for us is identifiers. So an ID used across several services. Sometimes it's best to keep local to the domain to make wholesale deletion, refactoring, adding better. Other times, it outgrows and it lives in all 5 of our backend services. So you do need those global crates. We have a crate called SI events, which is just all of our IDs for everything. But what makes that great is the IDs itself are a domain in a system. So it's as Adam said previously, this isn't the kind of thing you nail by precision on the first try. We had IDs all to one crate, and then they started spreading everywhere, and then we wrote a global crate for them, which may feel backwards given what I said about util having like a big data bag thing. But so long as you're operating based on behavior, you can make these changes much faster. We also optimize for build system behavior as well. Rust in particular likes when you have many crates rather than fewer crates. Compilation units can be handled in parallel on multi-core processors much better. So that's like a small tidbit. It's a little off topic, but I thought I'd call out anyway. Your specific languages will dictate how you lay out the code base too. Python, you have to deal with a bunch of pathing stuff. Rust, we have to deal with long compile times. Everybody's situation is a little different. Okay, it's a lot of text. So let's come back to what's the most important thing here, and that's maximizing opportunity time and setting up the code base for it. And I'll reiterate the big goal, which is to enable and maintain our code base to do so, right? We want to make these changes faster than ever and make sure we're not drowning by tech debt. And you want to feel like, yes, I can make that change. I'm going to have this big red diff in my PR, not the, oh my gosh, that's the thing that Mike started back in 2011. Nobody knows how it works. Please, dear God, do not touch that. We want to avoid those situations. So let's go do it. I gave you a little bit of stuff to bat out with, the domain-driven design book being a particular motivator for me, as well as some other examples in our open source repository you can check out or just come and talk to me about as well. But basically, those short-lived feature branches, those rapid iteration, all that changing, code base laid out by domain and behavior, keeping it supple and not just by technology or random data bag type modules. We're going to be able to do all these things so long as we keep that opportunity cost in mind and make the code base easy to refactor and work around. And that concludes my talk. Thank you very much, everyone.